Oh, I'm so sorry. I was muted. I was muted. Right. Welcome back to the stream because I was muted for like I don't know how many minutes. How many minutes was that? Oh my good grief! I'm so sorry. That was 5 minutes. Sorry, 5 minutes. I was muted. So yeah, welcome back to the stream. So today we're going to be looking at a couple of things, which is things like CDP, for example, that we were just looking at there, the native VLAN mismatch of that particular switch. So we're going to tackle that first. And I've got a couple of other things that I want to have a look at, which is more around the NAT stuff, because what I found was I was supposed to do some NAT stuff here. So let's do a couple of things first. So what I want to do is I want to go through NAT. So we'll do the en conft. Oh, come on, conft. And then it was IP NAT, I think it was. I need to do inside, and it was source. Now this part is where it gets interesting, because there's a list which is attached to the access list, if I remember correctly. So I think it's, you know, I'm going to do a do show run because I'm not sure what exactly I writ. So let's do a do show run. And there we go. There's a NAT pool. So the NAT pool is there, right? And we have our access list at DCNet, right? Which is taking in our extended access list, which is supposed to be at the source, right? So wherever the source is of that, that's where it's supposed to be. We don't exactly have the source here, which is interesting. So it's not necessarily a good thing. This should have been a standard access list as opposed to an extended. But we could use an extended here, no problems. It just means that when we try to go out of the network and then back in, like we saw the other day, it's going to do a destination. It should be a destination unreachable, but it's not. It's actually going to end up becoming a dropped packet. So it's going to be completely untenable. That's really the only difference. But you could have it here, no problem. And the reason why I say that is because there's an implicit deny at the end of the IP access list. So it doesn't actually make any difference here. So the thing that we've got to figure out now is, well, is how to do the binding. That's why I was so conscious about the IP source, the IP NAT command. So the IP NAT command, and then it says inside, right? Because we want it on the inside of the network, because that's what's going to do the resolution for our pool. And then we have source, and we want not a source, but a list, which is going to be the local address binding. So I think it's going to be list, and then the word, which is going to be the local word for the binding. Now, I can't remember if that's for the pool or not, so I need to double check this. But it should be something like this, I think. The name of the pool. Okay, so that's actually the access list. So our access list, what was it? A named access list? It was a named access list, which was DC_net. So DC_net, right? And then that should have been a word. List. Yes, list. List. Word for the local address. Access list name. So this is the access list name. Our access list name was DC_net. Okay, DC_net. And then our pool name was actually going to be DC_net NAT pool, which does the bindings from the inside of the network. So our inside of the network is running on the 10.0.0 network, right? But our actual NAT pool is doing the address translation to DC_net NAT pool. So what happens there is those particular hosts that we configured the other day, what's going to happen is that it's going to end up allocating those external IP addresses that we had created in that NAT pool. So now what I've got to do then is go down here and then put that down here, which will create the binding, and I could overload it if I wanted to for the translation of all the actual IP addresses on the inside of the actual pool to the outside, which means that I have like 5 different addresses on the outside going back to that one external IP address. But in this case, we don't need it. So there's no need to do the overload, because then we're doing port address translation on the pool, which isn't necessarily a bad thing, but in this case, I don't think it's worth it. So I'm just gonna do that. Okay, end it, and I'm gonna do a copy run start, and we should be good with the translation. What's the problem here, though? Well, let's have a look. See here, right? There's a couple of problems here. The first one is that we don't actually have a route down to do any sort of translation. That's a problem. Yeah, that's a problem. The other problem is that I could have done the port redirection, to be honest with you. I didn't do the port redirection. Is that a bad thing? No, it's not a bad thing. Voice, sorry, AH22. Let me just get that. Is it too loud or is it too soft? Like when you say the voice. You're on the stream before. Oh yeah, sorry about that. Yeah, you're absolutely right. Yes. That was because I had it on mute. I'm sorry about that. It should be fine now. But thank you for telling me. Appreciate that. Yeah, what was I? Yes. I didn't need the port redirection. Why did I not need the port redirection? Because in the real world, when we do real server administration through things like Nginx and Apache, right, the actual port can be 443, it can be 80. Usually for SSL, it's 443. So a port redirection on the inside doesn't actually make that much sense, because if we have an external server inside of a data center, like we did the previous day, right, that port number of 443 usually is handled by that load balancer, being Nginx or Apache. So we don't actually need to do any redirection. The redirection is completely invalid, to be honest with you. The only thing that we're really interested in is the port address translation in the real world because we want to conserve IP addresses. Hence, we use NAT. Yeah. And we wouldn't be doing what I did in this particular scenario, which was the actual pool of addresses being allocated towards these different servers. That was just there for the demonstration. So we have a number of problems here in this architecture, which is, well, we have OSPF, which is linked to each of the other sides, but our links are not in place. This is a problem. Despite having inter-area OSPF, we don't have any connectivity to go back to where the actual NAT in Area 51 is, right? We can't see the aliens. We can't see all that stuff. We can't see, you know, all that stuff that they do at Area 51, right? In, what was it? Is it Nevada? I don't remember. Anyway. So, what do we do here? Well, the first thing we need to do is get this working. But we also have other problems in this network. So other problems in this network are basically that we have a native VLAN mismatch. Native VLAN mismatch is down here on the switch. Yeah? And I was talking about CDP the other time, whereby we have Cisco Discovery Protocol and the reason as to why we turn it off. So for example, here what I've done is I've run the CDP entry command, which is basically this command. So show CDP entry star. And the reason why I've run this is because I want to get you to see that we can see all the different devices connected through CDP, right? Cisco Discovery Protocol. So as I go down, right? In this case, I've got one switch, right? A couple of switches which I can see. So what's it telling me? Well, I can see through here, it's running, I can see what the device is, what the software version is, which is 17.12.0.1, what the actual operating system is, right, which is Cisco iOS XE, and I can see some other things in here as well. Yeah. In fact, if I run CDP correctly, I should even see a couple of other commands in here. So I can see, okay, it's sending, that's great. But I should also be able to see, for example, the interfaces where it's doing it. And I can see that there's a number which are down. But if I do it correctly, I should even be able to see the actual IP addressing. I think in this case, I don't actually have any IP addresses on things like the interface VLAN, which is why I can't see anything, which is actually a good thing for security. So, how do we get rid of something like the native VLAN mismatch? Well, first of all, we need to see where it's coming from. So I can see a switch 02. So where's 02 in our architecture? Well, let's do a show IP in brief and see if whether or not it's on this particular switch. Okay, so what does it say? We have 13, which is on our switch, which is up. Nice, no IP addresses. Going to 025. Sorry, gigabit 02. Gigabit 02 is going to be down here, right? Because you only have one for the trunking. So if we have 02, which is on a different VLAN to 13, right? So 13 is on VLAN 5. How do we do that? How do we do that? Anybody in the chat know? How do we do native VLAN? How do we switch the native VLAN inside of a switch? I'll give you a couple of seconds. Okay. So not a problem. The way that we do that is we go down here, go to the switch, and then what we do is we do a conft, and then what we're going to do is we're going to do a switch port on the interface. So where are we? Oh, we're in the wrong one. Okay, we're in 5. Okay, that's fine. No problem. No problem. So we need to go down to the actual affected switch, right, which is this one down here. And just before I do that, what did I name the host name here? Sales department, right. So I'll call it sales department switch, right? So we'll do, see, and it's telling us down here in the other switch that there's a problem. So I'll do EN, I'll do the host name, and I'm going to call this sales department switch. Like that on the host name. Because I haven't done the conft, that's why. I'm going to be careful there. And then host name, that one. Boom, boom. Bam. And we need to do a interface G, where are we? G02, 0/2. Switch port, native, switch port trunk, native VLAN 5. Okay, and that should sort that out. Copy, run, start. Okay, cool. So that should sort out our native VLAN. So let's do a show interfaces trunk, and let's see what's going on. Okay, we haven't got one, which is interesting. We should actually have an interface which is trunk. So let's see what's going on here, because I wonder if I was meant to have because this looks like I'm meant to have DHCP here. So do I have DHCP? I do not. So we have one sales department which doesn't have DHCP. Typical. So what are our subnets that we see? 8, 7, 5. And anything in here? What was this? 10, 11. 10, 11, but we have sub-interfaces on 5. Oh, I remember. Because I was meant to do... Okay, I remember this. Basically, I was supposed to do VRRP, and VRRP is supposed to be done at this point here. So this is actually wrong. I was not meant to do that. I should actually clear this up, to be honest with you. So we'll do that in a bit. Let's focus on this port here. And let's do our hot standby redundancy protocol. Okay, so do we have this native VLAN mismatch sorted, which we should do? Let's see, show. Can I do... Oh, I probably could do VLAN as a native VLAN, but it let me... No, it does it in the summary. Show... I think it's show switch port. Show switch port, I think, is the command. No. Okay. IP int. Can we do VLAN? Okay. Show IP int VLAN 5 does not exist. Interesting. It is actually the native VLAN. How do we check native VLAN? Show VLAN. Show interfaces. Hang on a second. Native VLAN mismatch discovered on 1.3 with sales department switch 02. I thought we changed the native VLAN. Did we not change the Yeah, we did. There we go. Switch port trunk native VLAN on G02. Still says it's 1. Okay. Well, let's have a look at how we can see this, right? Native VLAN mismatch, but we changed the VLAN. Interesting. So this is saying on 1.3 it's 5. Okay. So what do we need to do to show the native VLAN? Show native VLAN Cisco. And I'm learning this as well. So let's have a look. Show int trunk. We did that and it didn't come back up with anything. Interesting. So maybe we need to configure a trunk, and that's why. That's not a problem. So let's see. Native VLAN's on 02. So 02 goes up. Ah, okay. Let's do this then. Conft. I'm going to do a conft. I'm going to do an int G02, which is our problematic interface. 0-2. And then what I'm going to do is I'm going to do a switch port mode trunk. So switch port mode trunk, which is actually a SWIMO. SWIMO true. That's a shorthand there. So SWIMO 2 just means switch port mode trunk. And we are up on a trunk. Let's do an end. Show interface trunk. And let's see what we have here. Native VLAN 5. Yeah, there we go. Native VLAN 5. So that's good. Copy, run, start. And we should have a trunk connection on 1.3. So there's 1.3. Ah, here we go. Look. Blocking. So we've done STP. STP, we've got BPDUs coming in. It's not sure whether or not it's the root bridge or not, which is why we're getting BPDUs coming in. So we could activate BPDU guard at that point, right? And that will help us with the STP portion, right? in that case. But let's, for now, just focus on one thing, and then we'll get on to the next bit. We'll do conft int 1.5, because 1.5 was discovered to be 5 as a native VLAN. But it says that there's a bit of a difference there. So are we on a trunk interface on 1.3? So let's do a show IP. Let's do a show interface trunk. So here's the thing. We've got VLAN 1 as a native. We should have a mismatch here. Because 1 and 2, right, which goes off to those. So if you go look at the architecture, 1 and 2 are these particular interfaces on the fiber. Yeah, 1. You got 1 and 2, 1 and 1. Yeah. So that's where it gets interesting here. But the one that we're interested in is 1.3. So let's go back and do some 1.3 stuff. So conft int g 1-3 switch port mode trunk, because we made the trunk. That's going to give us a native VLAN mismatch, or it should do. So if I go back to our show interface trunk command, so we'll do a show in true. Right, now we've got a native VLAN mismatch because our native VLANs are wrong. What it should be is on native VLAN 5. Although, interestingly enough, we don't actually have the error. It's interesting that, right? Because we hadn't... There we go! There we go, boom! We are there. That's what we were looking for. That's the message. All right, let's get in there and solve that issue. G 1/3, and the same thing, switchboard, mode, switchboard trunk. Right, switchboard trunk, native VLAN, 5, end, copy, run, start. Boom. Show interface trunk. Right, we're on the 5. Good. That should sort it out completely. We've got the trunking in, we've got the native VLAN in, which is good. So we've got our native VLANs correct. Copy, run, start. And we're good. Sales department is now up. Yeah? Only thing missing is DHCP, right, on the sub-interfaces. And then the other big problem that we have is going to be our hot standby redundancy protocol, where we then need to switch between the standby and what is the active switch in this case. This is going to be the layer 3s. Yeah? Okay. So what's the problem here? Because I've just thought about one. Anybody can tell me what the problem is here? So problems here that we have is there's quite a few. And this is what you don't get when you do the standard Cisco CCNA based labs. Because what I find with the standard CCNA based labs is that they don't get you thinking enough for these particular architectures, because these are the sort of things that you could find out in the real world. We have a layer 3 switch. Now in the layer 3 switch, normally what you can do is you can do an encapsulation.1q, all right, for your layer 2. So if you're studying CCNA 2, this is going to be CCNA 2 topics. In CCNA 3, that was the net IP address translation that we did about 20 minutes ago, odd. So problems that we have here architecturally is that Cisco CCNA packet tracer doesn't allow for .1q and an IP address pool in a trunk to the PCs on layer 3. I know it's a bit annoying, to be honest, but for some unknown reason, that's how it works. So it leads us to a couple of things that we could do. We could have an access port, which is probably the most appropriate thing that we can do here. With the native VLAN, I'm not so sure if that will work, but we could try it. And basically what that means is that we have DHCP for one particular pool of IP addresses rather than the sub-interface. That can work. And it was basically what I did yesterday. And then we have a separate subnet for the load for our VIP for when we change between what is the standby and the active switch, right? Which is carrying our load up to the router. That could just be a static route, to be honest. We could use a default in that case and then just do a default static route. Or we could use OSPF. The problem that I have, right, with things like default information originate, which is in CCNA 3, is when we have a static route, the administrative distance of the static route is 1 compared to 110 of the administrative distance of Cisco's, for OSPF even, for OSPF. And that's where it gets kind of annoying, right? Because you do the default information originate command, and by doing that, what happens is you end up with something called an E2, an OE2, inside of the IP route command, which is fine. But like I said, the administrative distance kind of negates the effect of a route towards OSPF if you're doing a default static route to begin with. So that's where I get a bit confused with that sort of stuff. We could try it for this particular lab. I think it's a good thing to try and a good thing to learn. And like I said, I'm going through this as well, so I have to think about architecturally how does this work, right? This is the one thing to take away from these particular labs in preparation for the CCNA, is not a case of saying, oh, well, I need to memorize everything for the question. You don't. You just need to understand, well, okay, how does this work in relation to a certain architecture? Because when I think about it that way, when I go in to do networking work, when I go in to do all that kind of stuff, right? Even if it's DevOps, if it's Cisco, systems administration, do Juniper, whatever it is, yeah? It's the same sort of thing, right? It's how does this architecture work in relation to what I'm doing? Because if I don't know that, how am I supposed to create a solution to build anything? Because, the fundamental architecture isn't understood. So that's what I'm thinking about when I'm doing these labs. It's like, okay, maybe I've done something wrong here. Have I? I don't know. Do I need to change something? Maybe. Right? So that way I can get things working. So, where was I with this? So I remember I did OSPF. I did OSPF here. This still needs work. This is good. But this is a trunk connection. So let's think about a trunk here for a second. So we have a trunk. Trunk tags the frame, right? So it's a tagged frame with the VLAN number, so that's fine. Our native VLAN is 5, which is completely fine. So we have tagged for our VLAN. If our VLAN is 5 or above, that should work, right? Because the VLANs which are allowed over it in the management domain is 1 and 5. So I could do encapsulation.1q and it would work with DHCP. Yes, it would work because I've got the that would actually yes, that would work. It's exactly the same. It's running as a root. Yeah, okay, fine. So let's do the DHCP configuration. Conft int, and then what was the one down there? It was 1.3. 1.3. Okay, G1/3. G1/3 is on, which is great. Now, what if I did? I think what I'm going to do, I'm going to do 5. So it's VLAN 5. See, and this is the thing that I really just. It's a layer-free switch, right? A layer-free switch is fine to have some interfaces, but it says in packet tracer only routers. So if that's the case, then all I can really do is create an access. I'd have to create as an access and leave out the trunking. Although really, I prefer it. Or I could. Okay, I'm going to try this. Because I'm not sure. I'm going to do an int G1/3 And I'm going to do a command called no switch port. So that would mean I turn this into a rooted port. Okay? Because what you can do is you can run a switch port. So with that, I'm going to go and do no switch port. And from there, I'm going to just say int g1/3. And I'm going to say, sorry, no, I'm not going to do that. int1/root/.5, and it still says routers. Okay. Okay. That's quite annoying. I'll just make a router then. Fine. Are there any interfaces on here? No, it's just 5.5, which is fine. Okay, well, we're just going to have a router here. That's quite annoying. So we'll do a 2901. And what we're going to do is we're going to open this up. I'm going to take out the configuration. From here. SFP. Module is not compatible. Let's go in. SMB like that. Put it in. Okay, cool. Done. Next. And... oh, we need two. Okay, we need two. And I think that's fine. Okay. I'm going to use the simplex. I'm going to go back in. Over here. And over there. 1.4. And then I'm going to create the trunk. From here to there. Okay. Alright. Let's go in here. Do a no. en hostname. I'm going to go call this sales. For hostname, conf t. And then we're going to go hostname sales. Like that. And I'm going to go and do an int on the subinterface, which is 00. Int g0/0 5. And I'm going to do an encapsulation .1q5. And we'll give it an IP address as well. So we'll say IP header 192.168. We'll call this 15.1. 255.25.25.0. No shut. And we'll exit that. And we'll go back to our interface in a minute. We'll do an IP DHCP pool. And we'll call this sales. The sales pool. And then we'll do a network, which is going to be 192.168.15.2. And we're going to do 255.25.25.0. Default router 192.168.15.1. And then we're going to do a DNS router, DNS server 192.168.15.1. And then that should be good. Exit that. And then we're going to go and go back to our interface, which is going to be 00. So G0/0, no shut. And we're up. Okay, cool. We're going to end that. Copy, run, start. Okay, good. Okay, let me do a show int trunk. Can we do that? We can. Don't have one there. So we can go conft intg00 swimo true. Will let me do that? No, it won't. Interesting. Interesting. So it lets me run the command. I can't do a switch swap mode true. Okay. That's cool. So we don't get to do a switch swap mode trunk on the switch, but basically what I've done, thank you for joining, is I've made the DHCP pull and I've added the sub interface and I've done the sub interface in to 15.1. So the only thing I've got left to do now is just to do the IP DHCP excluded address. So I do an excluded address, and then what I'm going to do is I'm going to exclude that 168.15 address. So 15.1, and I'll end it and I'll do a copy run start. All right, cool. So now I should have DHCP on this side. So I'll go down here, IP config. Yep, there we go, 11, everything's good. So I know all these other ones are going to be good. Now the real problem comes here, because we've got to do our subnet in to basically say, right, okay, when the VRRP, right? Because technically I think it's VRRP in Cisco. I'm not too sure on that, but I'll double check. We have VRRP, yeah, and basically what we need to do is we need to say, right, okay, when this goes down and when this is active, yeah, we need to come back up and down. Now this hot standby redundancy protocol which does this, and the problem that I have with this is that there's a couple of ways that this could be done. So you have like HSRP, which is the one that I know, and there's like, you know, other kind of protocols out there as well. I think there's 3 in the CCNA, but again, it's a bit kind of convoluted. So with this, I am going to, yeah, you know what I'm going to do? I'm going to create. I need to create a VIP. That's what I need to do. I'm just trying to think what the best way to do that is. In order to create the VIP. So here's what I'm going to do. I'm going to go on the internet. And I'm going to show you guys what I do in these kind of situations. And I am going to check hotstand. So what I want is a standby redundancy protocol. Yeah. So I'm not familiar with HSRP. So I want to do HSRP. And then I'm going to go do the config, because I remember it's something like standby. Here we go. Yeah, so we got the interface of the terminal. So I remember that. Standby version 2, that's correct. Now we've got the IP of 1. Okay. And then priority. So we do the preempting. So I need to track the fiber interface and say the priority and then get the traffic to move in a particular direction. But I thought there was a particular VIP that I need, don't I? There we go. A virtual IP address to the standby group. This is where it becomes problematic for me because of the subnet. Because of the subnet. And the standby group is on, see, it's 1254 here. The interface going down is correct. So if I was to have 2 separate IPs, would that work is my question. I'm going to check. Because I'm curious to see myself. Network Lessons is a pretty good one, by the way. If you're studying Cisco, Network Lessons has some pretty good stuff in terms of what you can do. So here is like, 13 and 23. Goes down to a switch. It's a very similar kind of scenario, actually. Goes down to a switch. We've got layer 3. Switch has 1. Okay, that's cool. So 1254 is the standby on the switch. So 1254 is here somewhere. I'm not sure what exactly is that doing? Is switch 1 and 2? So switch 1 and 2 have the same standby IP address. Really? So host 1, okay, 100. Default gateway is 124? Okay. Interesting. So you're preempting on the gateway. So H1 is a host. Interesting. H1 is a host. Very interesting. SW1. Wow, people don't want to learn Cisco. Crazy. SW1, yeah, 13.1.1.1. Somebody's 1254. Thing 1254, SW2. No switch port, 23.2.1.2. Standby on 1254. So the interfaces are different. Oh, there's different subnets. Okay, so they're different subnets completely. Going back up. So if they're different subnets, and then H3, so R3 is this one. So 1254 is what? Belongs to VLAN 1. Okay, switch 1 and switch 2 are multi-layer switches. The 192.168.124 subnet belongs to VLAN 1, and there's one host. So that's the... Ah, it's the same thing. So we've got 5. Ah, okay. So we have 5, which is our switch. Now the virtual router in the middle. Okay. So it needs to be on the same subnet as... So is it 1.254? It is. Okay. I've got it. Okay. So what's our configuration? Standby 1254. Right. Okay. Got it. It doesn't matter. Right. Okay. Okay. So here's what we're going to do for HSRP. For HSRP, what we're going to do is very simple. We are actually going to have 2 different subnets going this way. Yeah? So I'm going to call this like 17 and maybe this like 18. So I'm going to do basically a conft int. What is this? 030? Okay, int g 0/3 0/3/0, no shut, IP address 192.168. I'm going to call this 17 because I'm not using 17. .1. Okay. I'm going to call this like 255.25250 just to make it simple. Bad mask. Yes, you're right. That is a bad mask. There we go. And that's a no shut, so that's good. Okay, so that's one done. Going to do end copy run start. Okay, and that's good. And that's up, which is great. And I'm going to do on this side 18, which is 020. So we're going to do a conft int g 0/2/0 IP address 192.18.1 255.25.25.0. And what have I done? Oh, here we go. So IP address. Do a no shut. Boom. And copy. Run start. Okay, good. Fine. That's good. And that's going to do STP. It's going to go through, do all that good stuff, which is great. Now let's go and do the preemptive stuff. So we need to create our VLAN. So we've got interface VLAN on our configuration on 1 and 2. But we have a VLAN 5. So can we get away with the I don't think we can get away with the interface on a router. We can try it. Interface VLAN. Oh, we can. Thank goodness. So interface VLAN 5, standby on the 1. Yeah. I mean, we could. It's gonna be neat. Oh, right. Yeah. Okay. Okay. So I actually need to do something before that and check the subnet of the DHCP server. So I'll do a show run. And we're on 15. Okay, cool. So we're on 15. 15 on the 5. Okay, cool. We'll do 15. Now, many of you are probably looking at that thinking, well, this guy has clearly lost his mind, right? He has 5 on the VLAN, 5 on the sub interface, right? And he's got encapsulation.1q of 5, right? Why does he use 15? Why does he use 15? The point that I'm making here with this particular argument is very simple. Even though you have an encapsulation of .1q5, right? That is the VLAN tag, so it makes no difference. In this case, all I've said is, anytime that you get a 15 address, tag it with 5. That's it. Now, what I'm going to do is I'm going to go through this and then create the same subnet. Now, I have to be very careful here because I've negated one particular process. So what I'm going to do is I'm going to do IP DHCP excluded address, and then I'm going to call this 254, like that. End it, copy, run, start. Done. All right. So that's good. Now I've got to get this working, and I'm going to create my VIP. So interface, what I'm going to do is just do a conft first. Interface VLAN 5 is up. IP address 192.168.168. What are we going to call this? Do we need an IP? No, we don't need an IP address. Okay, that's fine. Even better still. End it. On the int. Okay. Interface VLAN 5. Conft int VLAN 5. And I'm going to do standby 1 IP, copy this, 15.254, which should be the excluded address. Let's see if we can do this. Is not within a subnet on this interface. Is not within a subnet on this interface. It's interesting. So we need an IP address. Okay. So we need 2, because if that's in that range of 1, yeah, maybe we need 2 then. So interface VLAN is 131.254. So I need another one. All right, okay, that's fine. Exit that out. We'll do another IP DHCP exclude address, and we'll just create that on 253. 253 because it's management anyway, which is what is? Oh right, okay, 15. Because that's useful anyway. And then we'll do the standby on the interface VLAN 5. We'll assign the IP address of 192.168.15.253, and then create that subnet there as well, which is 255.255.250. And it says it overlaps with 05, which is correct, but we kind of need it to overlap, because if we didn't, it wouldn't create the damn... Okay. Overlaps, yes, but that's what we want. Okay. IP VLAN 1. Okay, let me think. So we've got encapsulation.1q is on VLAN 5. but we're not allowed to overlap it. So how are we supposed to? Interesting. Interesting. All right, let's have a look at this. Let's think for a second. So we have a virtual router on HSRP, virtual gateway. Virtual gateway goes from GRP1 state, which is our load balancer on interface VLAN 1, but it's separate. It's separate. Okay. Okay. So if it's separate, we don't actually care. Oh, I've been a bit of a... Okay, fine. We don't actually care. We don't actually care. I have overcomplicated this. Right, go back to int VLAN 5, drop the IP address as being something like 192.168.20.1, 252.5.2.5.0, because we don't actually care. It's fine. Because the actual interface itself is on a different subnet. Very important. So we'll end that. Copy, run, start. So it's on a different subnet, which is what we want. Now we can go in and do the interface VLAN 5. Standby 5, right? Well, standby 1 actually. Standby 1's better. IP 192.168, and we want 20.254. Yeah? 20.254 on the VLAN 5. Let's do that. Okay, that's put it in standby mode, which is good. Switch. So the other switch now, I've got to do the same thing, right? But it's going to be on a different interface. So same VLAN, different interface. So we have 2 on the virtual. Okay. So 1 and 2 goes up here on the virtual. So 3, 2. So why can't we just do that from 2 and then do that as a standby? That should work fine. Yeah, that should work fine. Because it would just switch over. Problem is it's not in the same IP address as the host. The host should be on 100. So even if it switches the gateway, it's going to be... It doesn't actually matter. Because it's not a default gateway. But it wants to be a default gateway. Interesting. Alright, fine. I'll come back to that because even though it's the right configuration, which is standby IP, it's on the wrong subnet, which is kind of strange. But I'm not sure that actually matters because, well, if we're switching it over anyway, the default gateway will be different than what's on the router. So I suppose what I could do is say, that's interface VLAN 5 and standby 1. That's an interface. So it's not going to care. But the other one is on a standby on the interface itself, which makes no sense. Because it needs to monitor, it needs to track. Oh, it's tracking the interface. Yeah, I forgot about that. Yeah, okay. It needs to track the interface. So how are we tracking the interface? R3 track? There should be a track. There's no track? Really? Oh, that's confusing. There's supposed to be a track on here. VLAN 1 standby, ping. 1254 shows standby. So there's a couple of states. Initial listen, speak, standby, active, VLAN 1 shut down. But it's doing it on VLAN 1 as opposed to track. How does it track the interface then? HSRP doesn't track interfaces. No preemption, highest IP address. Highest priority or IP address. Let me have authentication. Track the interface, yeah. Interface VLAN 1, track standby 1, track decrement. SVLAN 2. Okay, let's end this. Alright, I'm going to have to go through this again because even I'm a little bit confused about this. So I'll go through that a little bit later on. But we've got NAT though, which is good. Right, okay, let's do some OSPF stuff, I guess. Got that down here, so we need simplexed up here. So in Cisco Packet Tracer, this is not right. So we've got preemptive packaging. I need to think about that because that's very interesting. All right, I'll come back to that because that's very, very interesting. And it's more a case of how I've actually set it up as opposed to the lab itself. Yeah. Let's do HSRP. HSRP. So it's usually going to switch between the router. Our one's on the router, which is interesting. Switch between two routers, which we do have. It's just the other way around. But what I'm interested in, though, is why is it such that... So HSRP, standby. Do we need a default gateway? Oh, default priority is 100. Okay. Okay. Okay, fine. Okay, I'm going to need to think about this from an architectural perspective because I think I've done something wrong there. Which is fine, it's all part of learning. But we'll get on with that later. So now let's put this in. 0, 0. And we'll do that. So now we have a bit of a path now. So we've got NAT on the inside here. This is the outside connection. And we've got, what's that on 0, 3, 0? 28, 17. We don't have anything on this side. So 209, 165, 117. Okay. So we'll just need to do this on this side. En, we'll say conft hostname, transit router, like that. And then we'll configure this through OSPF. But we need a passive interface here. Because we don't need we need a passive interface, yes, but it's going to be a passive interface on this router here. So let's configure this. What is this? 17? What? 010. Okay. INTG 010. Do no shut. IP address is going to be what? En show IP and brief. 17. 240 on the subnet. So let's get this up, put that down there, and we will do 18, 255, 255 dot, and what was the subnet? 18? What was it? 28? 28, so it's 248. Yeah? 248. 248. All right. Exit out of this. OSPF. Right. Router OSPF 1. There we go. Network is going to be this and 4 in. So what is that? 128, 64, 32. Sorry, 128, 64, 32, 16. 16 is the network. So we need to do this. Dot 16 wildcard bits, 0.255. Area, what is our area? Do we actually have an area? It's 51. Okay, area 51. Area 51. We could do the autocast and all that kind of stuff. We don't need passive interface. Router ID. Oh, router ID, yeah. Could be done on the local interface. So if I do a local interface with the router ID, that could work. On the 222, makes more sense. So exit out of that. Router ID, router-ID. And I forgot, I think I got a 222 somewhere. I'm now on 122, so I'll call this like a, I don't know, 8.8.8.8 for router ID. How about, oh, right, okay. Go back into that process. Okay, router OSPF 1. Router ID is 8.8.8.8. Clear OSPF reload. Okay, cool. All right, clear. And we go to the end. It's clear. IP OSPF process. Yes, and that's good. Do we need to translate it out? Yes, actually. Conf T. And we'll do router OSPF 1. Network is going to be, what's 8.8.8.8. But it's not an IP address. But it is a 32. So there'll be no... OSPF returns tricky with this. Okay, well let's leave it for now. Because what happens is OSPF does this weird thing where it says 000. It doesn't accept 32s very well. So we'll do a copy run start. Okay, we are advertising out. Not necessarily needed because it's it's directly connected, so we're not going to see OSPF go through it, but it's necessary for the OSPF connection. This is area 51 on 030. So I'm going to do a conf T, router OSPF 1, and I'm going to do a network, and then I'm going to say on the 16 for this again, just 17 subnet, 16 on that, we'll do 000.255, area 51, router ID is 7.7.7.7, and then we'll do a clear IP OSPF process. So we're going to end that, clear IP OSPF process. Yes, copy run start. Okay, so we've got that going in there. Passive interface. So passive interface needs to be done on G00. So conft int g00. Now I'm trying to think. Is it OSPF passive interface? What's the command? Because it should be. I think it's IP OSPF, and I want passive interface. This is network type with the. Okay. Let's see. This is. What passive interface was on the interface? Passive interface OSPF. I'm sure it's on the interface. Ah, okay. It's in the wrong mode. It's not on the interface. It should be, but it's not. So it's router OSPF1, and then we need passive interface, and then it's the interface version, which in this case is going to be 00. So let's see, what do we need? Gigabit Ethernet, and it's 0/0, and that should be fine. And that copy run start, because we don't need OSPF messages going into the LAN section of the because that part is all LAN until it does the NAT traversing into the WAN. Yeah, so that's what we need to be wary of. Copy run start. Okay, good. That should be fine. All right. So NAT traversal's done. We've done that part there. Same sort of thing needs to be done on this side, which is fine. And we also need to do some other stuff here as well. So we've got NAT, which is done, standard and extended. DHCP we've done, VLSM we've done, IPNet. IP net address translation is done. We've done some static routes. OSPF priority we haven't done, because we haven't done druther. So we'll do that in a minute. And that's going to be done this side. So I need an IP address now. What have we got? We've got like so many different IP addresses on this. We need a 252 going from here to here. Let's just make something up. These are all inter-area networks anyway. So area 0 into area 51. So there's area 51 here. That's not going to work if I call this something different from the backbone. So this actually belongs here in the middle. It's another ABR. So this is an ABR called Area Border Router in OSPF. I have another one here, which is another ABR, which is this one here. So this is why if I do a show IP route in here, so I'll do an en show IP route, right? I should see inter-area OSPF here, which I don't, which is interesting. I should do. And I might, yeah, I will do later. I will do later because it hasn't actually reached this part yet. It's got a 444 from somewhere. So run. Is this one with a 444? Oh, it's on the loopback. Okay, and I've just advertised out the loopback. Yeah, done. On area 0. Okay, cool. So all I need to do there is basically say on here, show run. And I just need to do a conft interface loopback. And what is this? 888, 808, like that. 252525 255. Why is this not interface loopback 1? Okay. I'm jumping the gun a little bit. There we go. Interface loopback 1. IP address. Put that in as needed. Okay, no shut, done. And then we need to exit out of that. Router OSPF1. Network is 8.8.8.8. And then we need to do not. Our area is 51, I believe. Let me just double check that. It is. And then area 51 like that. End, copy, run start. Okay, and then show run. And we're good. Okay, cool. This side has a network for redistribution, which is 10. Conft int. Oh no, we don't need to do that because that's on. Do we need to do that? Let's see. Because it's got nat. Oh no, we need to do the nat. Yeah, it's nat in it. Okay, this will be a different subnet. We need to redo. We need to do distribution of nat, but we've done that already. That's fine. So that would resolve. That's fine. That's fine. Okay. Let me think. Oh right. Okay. Yeah. Fine. So what have we done? So that's going to be there. Int loopback 1, and then we need to do IP header. It's going to be 777, 7777, 245, 245, 255, dot 255, no shut. Okay, exit out of that. And we need to do a router OSPF 1 network is 7.777, area 51, and that copy run start. Boom, done. Okay. Now we should see in show IP route. Okay, we've got direct connected networks, which is fine. That's fine, but we're not seeing 7, which should be advertised. Is 8 being advertised? Show run? It is. It's on area 51. Area 51 should be seeing that. We aren't, which is kind of strange. For the router ID, show OSPF, IP OSPF. No. OSPF, yeah. Want to do neighbors? Yeah, do neighbors. You have an OSPF neighbor? Really? Show IP OSPF interface. Loopback 1 is up. Cost is 1. Designated router is 777. That's correct. Priority is 1, which is correct. Interface address is correct. Hello waiting timer. Another hello is due in a second. So I think once that hello goes through, we should, or we were supposed to see a 7 and 888. We're not seeing an 888, which is interesting. In area 51. So show IP route. We have an 888 directly connected on the loopback. So it leads me to believe that we need to do a clear IP OSPF process. Yes. And on the other side, do the same thing, which is clear IP OSPF process. Yes. Do a show IP route. And we still got 7. We should have 8. Let's do a show run. Something's not right here. So 7 is on OSPF. We've got... here, look. It's on 0. Which is incorrect. That's why we're not seeing it. Okay, conft router OSPF. OSPF 1, and then we need no. And then we need to go back here. Control A. to go back here, and then what we need to do is we need to say this is 16, okay, and that, and I'm going to do a copy run start on here, and then what I want to do is I want to check whether or not we have neighbor relationships. So I'm going to do a show IP OSPF, and what do we have? We've got hello dead timers, which is good, area 51, and we have 777, which is good. So show IP OSPF neighbor is the one I want. And we still not got a neighbor, which is interesting. So we should have got a neighbor. But we don't have one. What about our interface? We should have. Okay, that's good. 777 is good. Up. 17 is correct. 16 should have gone through, which it has on area 51. Our hello timer is doing 8 seconds. 4 seconds. 3, 2, 1. Now. And then 9. Okay, so every 10 seconds. So does that mean we now have our neighbor relationship up? It doesn't look like it, which is interesting. So show IP root. We should see an 8, but we don't. We should see an 8, but we don't. So what if I did a clear clear OSPF. Clear, should be OSPF, come on, IP. Clear, come on, clear, thank you. And I want IP. Should have OSPF in here as well. We do have OSPF. OSPF. Process. Okay, next with the yes. Okay, cool. Show IP root. And we still aren't getting one. Why are we not seeing 8 and why are we not seeing 7? Show IP root. We've got 8 and 7. So can we ping 7? No. Which is weird. We should be able to see it. It's 18. 18's on the 32. Wait, what? So 16, 29, 18, 32. 1832 is directly connected. That's our interface, isn't it? Yeah, it is. I'm on a 248. And I've screwed up the wildcard mask. Right, let's do this again. Because I've not done this correctly. Conft. Put that in here. Do a no. Router OSPF1. We'll do a no. Put that in here. And we're going to do this again properly because this is not correct. 16. We're not going to do that. We're going to do it a different way. We're going to do 255, 25, 25, 248 and do the reverse mask. Right, end that. Copy. Run. Start. Okay, now that's correct. That is what we want. Okay. So that's good on that side. What about this side? Let's check this. Show run. And it's incorrect here as well. So we need to do a router. Conft router OSPF1 no bung and oh actually what we want. Okay, what I'm going to do is I'm going to claim that, move this because this is wrong, and then I'm going to correct it by going up, and I'm just going to run that in there, which is what we want, and that show run, and that should have done the auto mask, whereby, yeah, there we go, 7 area 51. That looks good. All looks good. Copy run start. Now I should have that adjacency. Show IP OSPF. I'm going to do a neighbor. Still haven't got any neighbors. So let's clear the process. Yes. And let's clear the process on the other side. Clear. Clear. IP OSPF process. Yes. Okay. Show IP root. And we still have an 8. We should have 7. Let's give it a bit more time because that's definitely correct. And we're still not getting the root. That's weird. Show run. So loopback's in there. ID's in there. Network is in there. Subnet is correct. Interface is correct. We might need to force the interface. I've seen this before on packet trace. It's a bit of a weird error. So we'll do a conft, bung that in there as an interface. We'll do a shut, no shut, shut, no shut. Okay, and that copy, run, start. Okay, I'm going to do the same thing here, which is conft, int. I've got 17. Oh yeah, IP not outside, that's correct. And this is 240. Hang on a second. Hang on a second. It's 28. Should be 0015. Hang on. So this 240. Okay. So that's a 240, not a 248. Ah, it's been a long day. 240 as opposed to 248. So yes, it's going to be on the wrong thing again. All right, we will get this right. We will get this right. I promise you. Right, there we go. So we've got 248, 240 even. I need to make a note of that. Yes, you can retry. It's not necessary. Fine. That's kind of weird. Take that out. Bung it back in. Okay. Okay. So en show run. So that's 7. It's not 7. It's 240. Let's get that right. Router. That's why we do. That's why we practice. That's why we practice. OSPF1. Down here. No. And we're going to do 240. 252525.240. Okay. End it. Run start. Fantastic. We are going to do the same thing on the other side because we need to. So show run. And we've got the wrong IP there, so conft, router OSPF1. And I'm going to do no network, blah. Let's get rid of the double network because we don't need it. Okay, cool. And then we're going to go here, network, and then we're going to go that end, copy, run, start. Clear IP OSPF process. I'm going to say yes. Okay, that's good. And we're going to do the same thing here, which is clear IP OSPF process. Yes. Okay, that's good as well. show IP root is still not showing what it's supposed to. Why? Okay, that's correct now, because it's on the same subnet. So that subnet's completely correct. That's fine. That's fine. That's fine. That's fine. So what gives? That's not fine, because that doesn't exist anymore. So conf t router ospf1 no 7, and that copy run start show IP root show IP root is still saying 8, but it shouldn't say 8. I should get a 7. Very strange. 52, 29, it says 29. 29. 29, 1629. How did it get 29? So it thinks that's a 29, and what does this think? That's the same thing. 24, 24. Oh, it summarized it. But it shouldn't be summarizing. It says 116. But 16 is a 28. And the 28 is on 240. 17 is on 240. That should be fine. Okay. Show run. And we have 18 on 248. So that's wrong, because it thinks it's a 29. So we need to fix that and make that correct. Okay. And then put this to be 240. Okay, and that. Okay. Copy run start, show run. Are we in the same ballpark now? We are. And there we go. Adjacency. Whee! Okay. That was more difficult than it should have been. But anyway, good exercise. So that is all correct. But these are certain things that can trip you up. Yeah? And that's why I make those mistakes. Because they're designed to get me thinking about how I'm going to go about doing this and where potential mistakes can happen in the real world. Yeah? And this was certainly one of them which, without careful detail, attention to detail, would have absolutely 100% tripped me up. 100%. But we got the adjacency. So now if I do a show IP root, right, I can now see we have the correct state, which is 777 from the loopback. It's working. I can see that OSPF is working, and that's great news. Good. So that one's done. In area 51. Now we've got to get this particular thing working now. So we need a 252 basically. What is this on? This looks like it's internal. Is this internal? No, this is external. This is 18. So I could do a 17 perhaps. What is this? Ah, this, okay, cool. So I could say a 208 maybe? Let's be adventurous. I'll call this a 208. done port security, we've done trunks, AAA NTP server. So I need an NTP server. I'll make this an NTP server. Service NTP. I'll enable it. This annoys me because I don't know. Apparently, I just need to do that. That's all I remember from the labs. To make an NTP server. So I'm going to use that, which is great. But I've forgotten what the NTP command is. Silly me. But that's fine because what I've got to do here is basically just put the IP address in. I'll put the IP address in. Can't get one, which is fine. Don't really matter. And I'll just call it, I don't know, 192.168. Actually, no. It's got to be. Okay. 208.165. Oh, 108. Okay, fine. 108. That's even better still. 108.165.60.5. Oh no, 255.255.252. Hello. Which means 4 is. Oh, this is wrong. That should be 6. 108.165.60.5. That is correct. Okay, cool. Good. Done. We don't need NAT on this side. I was going to use NAT, but we don't really need... Oh, we could use NAT. I wonder if NAT would... Yeah, it would. Okay, cool. We'll just use NAT, actually. We could use NAT. That's actually better still. And then map it across. Yeah, that's actually better. 192.168.30.5. Sorry, 30.2. We don't need that. We can just call it 0. That's fine. 192.168.30.1. And that's it. That's good. All right, good. We'll go down here. We'll go en conf t. Conf t. Whoa, conf t. Host name is ntp net. And we'll just do an interface on the inside. What's the interface on the inside? 0, 1. Okay. G0/1. We'll do a no shut. Sweet. IP address 192.168.30.1, 255.255.0. No shut. Make sure it's done. And we're there. Good copy. Run start. And we're good. Okay. And what have we got here? 0, 0? All right. 0, 0, en. Whoa, okay. En, I'm going to do a no IP domain lookup for this because this kind of gets annoying. No IP domain lookup. Okay, cool. And I'll just call it hostname. Call this ntpnet. Like that. Interface 0G00, which is invalid type. That's interesting. Where are we? Here. It does say 00 is a valid type. Hello? 01. Okay. G01. No shut is not coming up. What's going on here? 0100. So I'll call this 0, 1. Is this 0, 1? 0, 0. What's this? 0, 3. Okay, cool. 0, 1 is... okay. So I'm going to use 0, 1. I'm going to go to 0, 1. Okay. 0, 1, 0, 1. And that looks good. All right. We'll do a NAT translation. So help me out with NAT as well. I'm going to do a conft int. Now our inside NAT is related back to 0, 1. So 0, 1s are inside NAT. So interface G01 IP NAT inside. And then our outside NAT is going to be 030. T G030. And I'm going to do static NAT because that makes more sense here. And we're going to do a IP NAT outside. And then we just need a standard access list because, well, what's going on in here is that there's just one IP address, which is 30.2. So anything on the 30 network is permitted. And that's going to be closest to the source. So the one closest to the source is on G01. So G01 is the one that's closest to the source. So I'm going to go exit out and do a numbered access list. I'm going to do IP access list 1, which is interesting. There should be more to it than that. IP access list standard, and I'm going to use 1, which is fine. Permit permit 192.168.30.0. Wildcard is going to be 000.255, which is fine. That's our access list. And then we're going to do, that should be on the inside NAT, to be honest. Because that'll be, yeah, and that should be on interface. Inside NAT. What's our inside NAT one? G01. Okay. G0/1. And then I'm going to do, what I need to do is called access, I think it's called IP access group. Yeah, there we go. Access group. Yeah. Because that's what is the one that's going to be applied to the interface. And then 1. And it should be type of in. There we go. So end that, copy run start. So that means that our access list is good. We're going to go conft and then go back to the NAT, which we need to do, which is IP NAT. And then we have not a pool, right? But inside source static and the local IP address for our server was 30.1. Yeah. So it's going to be 192.168.30.1. And now we need our inside global, which is basically our outside IP address, which we said on our interface was going to be, what did we say it was going to be? Anybody remember? Because it's undefined. Okay, that one's on me. That one's on me. But we'll add it. We'll add it. Let's just see. Do we have anything set? No? Okay. So we'll call it something like, I don't know, 108.165.10.1 as our external. And that's looking pretty good. That's actually bound now, which is good as well. I'm trying to think, do we need anything else on that? I don't think so. Okay, I'm going to double check that. That looks good. Copy run start. Oh, right, yeah. Well, it helps if we had an interface, wouldn't it? So int on the outside of our interface, right? This is 108. So outside of our interface, is going to be that. So int is going to be no, hang on a second, where is it? What's out in outside NAT? Outside NAT, where's outside NAT? Might be not outside. G030. Okay, G0-3-0. Bung, bung, bung. IP da is that one, and then we just need a 252 because the other side's going to be fine. So 255.25.25.252. 252 done. End copy run start. And we also need to do router OSPF. So we'll do a router OSPF1. And then we'll do a network because we need a network. And it's going to be our 252 net. And that is actually pretty good. 108 down here is what we need to take. And what we're going to do with that is we're going to do a 003. So we're going to do a network with a mask. So it's going to be 00003 because it's 255. Area, we're going to call this 10 because I can't think of anything else. And that should be good. We'll do a router ID and we'll call this, I don't know, quad 9. Which is good. That's looking pretty good. We'll exit out of that. Interface loop back 1. And then we'll call this IP address 9999. Sorry, 9.9.9.9. 255.255.255. Exit out of that. Router OSPF1. And then we'll do a network, which is going to be 99999. And Wildcard master 0000, area 10. Okay, cool. And that copy run start. Okay, cool. And we'll just do 10 on the other side. Okay, which is all good. And we need to do the same thing on the other side. So what's this? This was 108. All right. En conft int 020 g0/20. And basically what I want to do is want to do our router configuration. Oh no, it's IP address. I'm always stressing with this. There we go. That's better. All right, make that 2.25.252 is interesting. Ah, okay, sweet. That was right. Hang on a second. What's going on here? 3.4. That's correct. IP address. ADDR. Do you need ADDR? That looks right. Okay, cool. Now shut. And that's good. 3 and 4 is 0. Yeah, okay. Router OSPF 1. Network is going to be basically this. Boom. Make that 0. Ooh. 252. And this is going to be area 10, isn't it? So area is going to be 10. That's a transit complete. And we do a router ID, do 10.10.10.10. And that should be good. Then we're going to exit out of that. And then we are going to do interface loop back 1. IP address 10.10.10.10. Oops, there we go. 9.25.25. Okay. Now shut. Go back to router OSPF. router OSPF1 network 8.8.8.8. Oh, sorry. Tens. What am I doing? 10. Okay. And then we want to do our not 3. Oh wait, 0. Sorry. And then area 10. And I think that's all good. Copy, run, start. Did we actually activate the let's see. We did. So show run. 10 is good. 209 is good. 0 is good on area 10. I think that's good. 252, 7168. 10, 0, area 10 is good. So should get an adjacency. Oh. 020. Show IP in brief. Down. Conf t 0/2. Conf t. int 0/20. No shut. Is still down. Okay. E1 start. What's going on with that? 030. Is that down? Okay. Show IP in brief. Is down. Conf t. int 030. No shut. And it's up. Okay. Should start seeing some adjacencies in a minute. Show IP root. Show IP OSPF neighbor. OSPF neighbor. And there we go. We've got 777 and 31. We've got full BDR. And we've got one which is DR other, which means that it's designated router in the other way. So it means that there's more than one router, which is really, really good. In this case, it's a point-to-point network, so it doesn't really matter. But because this router is a three-way router, which goes down to that, it becomes more problematic. This one would be a point-to-point. This one would be a point-to-point, but there's no point because there's no point. How interesting. Because there's more than one. So yeah. Show run. And let's have a look. We have statics on the inside. Yeah, that's good. Good. IP access group 1 in. Yeah, that's good. In fact, we should even be able to get the NTP server off this. Out of the NAT. So if I've done NAT correctly, I should be able to get NTP. Okay. Let's see if we can get NTP on this side. Okay, we've got the exchange, which is good. So show IP route. And 7, 8, and 10 are connected. Okay. I'm not seeing much more than that. Although I do need to do a clear IP OSPF process. Yes. Okay, good. I need to do flush on this as well. Clear IP OSPF process. Yes. Okay. Adjacencies is now being reloaded. Show IP OSPF is looking good. Show IP root. is not looking so good. That's a bit annoying. Probably needs a minute. Okay. Still the same. Packet Trace has this weird thing with OSPF where it doesn't actually load correctly. It's a bit weird. I don't know why, but there we go. Yeah, Packet Trace is being weird. I'm supposed to be seeing 888 here as well. That's very super strange. Especially on the inter area because there's an ABR. So I'm supposed to be seeing OIA, which means that it's supposed to be OSPF inter-area networks, but for some reason Packet Trace is a bit naff on it, which is really annoying. So yeah. Okay. So that's that. Kind of annoying. What else do we need to study today? VPN. We do need to do VPN. Overload. Yeah, overload. Back to one IP address. Have we done that on this one? Was this one? Oh no, this was multi. Overload was here, wasn't it? If I remember correctly. So en show run. Access 1 is permitted on 10. But I didn't do an overload. Oh, I did. Here we go, overload. But I did a static. So I did a static assignment and then I overloaded it. Why did I overload to a static? There was no need for a static to overload and then do a port redirection. It would have gone out on 20. Okay, so that one's wrong. Don't need that. The overload was fine. It would have just muked it. So we don't need that. That's kind of silly, to be honest. We're doing a port address translation. So we don't need a static. We don't need that. Okay, cool. Copy. Run start. Okay, cool. Done. All right. HSRP I'm going to go through tomorrow because I'm not sure what... I'm still a bit confused with HSRP, if I'm being honest. And it's kind of annoying because I need to get this working. And it's taking me a bit more time than I thought. You know, because these are big labs. These are big labs, my friend. I've still got NTP to do. So I'm going to try NTP, but I'm going to do it for the NAT. I want to see if it works. So I'm going to do NTP for you guys. And basically, we've got passive interface 2. Now, passive interface, before I do the NTP, I'm just going to look at the passive interface. I'm going to see, you know, I think I did put a passive interface in. I didn't? You're having a giraffe. Alright, fine. Conft int. Which one is this? 01. Okay. So we're going to go router OSPF1. Because I thought I did this. Passive interface. Gigabit internet. Ethernet 01. And copy run start. Alright. That is now good to go. Gonna do the same thing here. For the OSPF, I did. Great. That's good. That's not going to affect these two networks now, which is awesome. This one's on a static, if I remember correctly. Just double check this. It is. Okay, that's fine. And what else do we need to do? We need to fix this particular link. Because this is on ABR as well. This is 10, 10. So why am I not getting a 10 network? I should be seeing a lot more routes, and I'm not. So what is going on here? Why am I not seeing the routes? 7, 15. 16 is correct. That's correct. Area 51. So area 51 on this side. What route? What? Why is this not working? I just don't understand why this is not working. 030. 030 is correct on 240. And 010. So show run 010 is 18 and correct. 165 100. Yeah, 165 100 0015. That's correct. I am really confused about that. So those two are correct. 108 165 102. 108 165 102. 108 165 101 252, which is fantastic. Ah, okay, that's good. IP access list 1. Yeah, I think that's correct. I think that's fine. That's so strange. I should be seeing more in there, but I'm not. That's really weird. 10, 7, 8 is not in there. 8 should be in there. I'm gonna have to look at this with fresh eyes because I'm a little bit confused by this. It looks correct to me, but it's not. Which is weird. 777 is fine. There's been 8 somewhere, which I think is local. Is it this one? 777, that's 10. 7, 10, 9. Oh, maybe it's... Oh, maybe that's fine then. Okay, maybe that's fine. Right, NTP server. So NTP for NTP is pretty easy for an NTP server. On a Cisco device. So configuration, you go for show clock. I'm going to go for show clock. And then this is going to tell us what it is. So we're on 1993. Fantastic. Fantastic. So we need to set the time zone. Well, we don't need to set the time zone. Oh, NTP server. Oh, okay. Well, we want to get it from the stratum. Then we've got a stratum 0. We can set the clock manually, but I don't want to set the clock manually. I need to get to... Oh, here we go. Ah, okay, conft. This is an NTP client. So conft, we're going to do NTP server. And I'm going to try and do this as the statically assigned... Oh, this is not a very good one to do it on. 108 IP. Why? Because I should be able to get to it without a port redirection. So let's go back here because I want to go on this one. This one makes more sense. Conft NTP, and it should be client. NTP client, I think is what it is. NTP server. NTP server. Want to wait. Okay. So show this. It's very possible this might not work. And show clock. So 93. Show NTP status. So it's unsynchronized. Oh, that's not good. NTP association. And it says it doesn't have an offset. It's thinking about it, which is interesting. Still says unsynchronized. And it's polling. So let's debug NTP events. Debug NTP events. What's going on? What's going on? That is correct. Oh, maybe it doesn't. Ah, okay. Cisco packet tracer doesn't support it. Let's do packets then. So if I'm looking at the association, so it's tried to take a packet to 108. Can we ping 108? Because my feeling is that I can't. Ah, there we go. There we go. We should be able to see that. So there's a bug. Interesting bug. Show IP route. We got 209. But we should be seeing 108 from the area border. Because it's directly connected. So it's not actually... Oh, this is weird, because it should be... So 108, 165.30 is set. Are we advertising out that particular... Alright, let me try on here. And I'm going to do a show... Because if that works, then that's telling me something. NT... Ah, wrong one. Okay, show NTP status. Unsynchronized. Okay, well that, that happens. NTP associations is going through. Status is still unsynchronized. Speed up a bit. Still unsynchronized. Is that... Ah! Oh, okay. I think I might know what's causing that. Can we send a packet? Okay, maybe if I do that. Yes, okay. Oh, okay. The device's clock is not synced. The device's clock is not synced. So it drops the packet because this device's IP address is not synced. So the packet is coming from the outside world. The device looks up its NAT table for necessary translations. The NAT table has matched dynamic entry for source and destination global address. The device translates the packet from global to local IP addressing with the matched entry. The destination IP address matches the IP address of the interface. The device dispatches the packet to the upper layer. But it says that in the decapsulation, the device's clock is not synced. Interesting. So I'm learning more about NTP as we go along. But the device itself is down here. So how does that one work? Phew, okay. I did not expect that. That is a new one for me. NTP is on. I do not know what exactly is going on with this, but I believe that's on. I don't know, 6 a.m. or something. I'm gonna leave this, and I'm gonna see if I can. Maybe I need to do NTP. Okay, let me try NTP here. Conf T NTP server. Try that IP address here. Oh, what happened? It just disappeared. Encapsulated device dispatches from the upper layer. NTP client sends out an NTP request. So it went through. Basically is what you're telling me. So if I do a show clock, wrong setting, show clock, 1993. That doesn't look right. Why is it not doing this? Okay, show NTP. Status is unsynchronized. But the packet went through. Why is it not synchronizing correctly? NTP association is out. Is that due to... The access list is not Is it? It is. It's on the inside. So why is that because of the access list? It's not doing that. Oh, let me try without the access list because I'm not sure if the access list is causing problems. Conf T. No IP access list. Copy run start. NTP associations. I want to try and see if maybe conf T server has that done the show. Let's see. Show NTP status is still unsynchronized for whatever reason. And why is it unsynchronized when it's so close to the server? Is that because of the switch? Is net address translation working? Show and show IP NAT translations. NTP. It is doing it. It is doing it. So what the bleeding heck? Why? What? So there's a what? There's a Yeah, it is being translated. What in the Sputnik is going on here? It's being translated. There's no firewall. Why is it drifting then? I am not understanding why that is drifting. It seems a bit odd. I wonder if, is that my server? Is my server doing that? IP server name, NTP server, I've done that. Associations, I've done that. Is it unsynchronized for me? There I can update the calendar. Okay, let me try that. Conf t ntp update calendar. Is that what was needed? Did that help in any way? And show ntp status Why is it unsynchronized? I don't understand. I don't know why that's unsynchronized. I have no idea why that's unsynchronized. It should be synchronized. Natural translation is clearly working. Otherwise, it wouldn't be. Oh, maybe it's got to be the server at this point. It's got to be something wrong with this, and maybe it needs to be here. Okay. And then still unsynchronized for whatever reason. No, still unsynchronized. I don't know. That is weird. I can see that there's a translation in NTP. It's still saying it's unsynchronized. I can see that there's a NAT translation, which is perfectly correct. It's going to the correct IP address, which is 30.1 on the inside to the the outside. I can see that there's one going in there. Wait a sec. 30.1. Yeah, so it's 2 on the 2. Okay. But I'm not seeing it on the other side. It's 30.1, but what's the... 30.2. Yeah, 30.2. And it's on. Okay, 30.2. And it's going to... it's not going to 30.2. 30.2 is not being translated properly. Why? Why is it not being translated properly? Show run. That looks right. Because that is the wrong IP address. Of course it's going to be wrong. Of course it's not going to work. See? That's why we've got to be so careful. So careful. No. That. 2. That's the static one that we want. End. Copy. Run. Start. And I need to double check the IP address. And device clock is correct. That's good. On whatever it is. But that's working, so that's good. Go to the interface, and it's 230.2, and we've got 30.2. IP translation is not set for the clock, so we need to set the clock. NTP server is 1. Okay, so in that translation. Let's see, show IP NAT statistics. 2 translations, which is good. So that looks good. That's looking good. Show IP NAT translations. And we have a translation. Good. So we should see our clock be synced. So show NTP associations. Okay, that doesn't look good. Show NTP statistics and status is still unsynchronized. I am at a loss. That is weird because it's clearly it's the right IP address. It's clearly saying it's going to NTP. So it's not wrong. It's Hang on a second. Why? Associations was 1. But the outside local is 2. The outside local is 2. The global is 1 though. Where's it getting 2 from? 2 is on the other is on another router. 10, 2. So inside to inside is correct. Yeah, inside. Yeah, that's correct. Outside is going to another router, but it's not translating correctly. So we've got 1081 to 32, which is correct. But yet, over the NAT, it's unsynchronized, which is so flippin' weird. It shouldn't be. Okay. Calendar, but it's not doing what I want it to do. Which is strange. It should have just done it by now. How interesting. Huh. Show NTP status is unsynchronized. Why? Okay, so if I do NTP server, put in simulation mode. Okay, good. Oh, is that why? Because I'm in. Maybe that's why. Okay, let me just. Still unsynchronized. What the flip is? But it has a drift. It knows the drift. So how can it be unsynchronized if it knows the drift? Associations. How very strange. No reference clock, but it's over the NAT. The NAT should be able to... It's over the network. What about the other one then? Is the other one reachable? Or is that not reachable? Show NTP associations. NTP status is unsynchronized. Okay. What is... Seriously, like, what is going on here? Why are we not seeing this? NTP server. And we've got 108. Alright, I see that. And it just disappears. But that's not right though, is it? So IP sort... But you haven't sent it off to that... Ah, okay. Because you're not in the routing table. But you... But this one is in the routing table, so why is this not advertising out? This is weird. Because this should be... This should be saying that there's an inter-area network present. Because it's advertising out of 10. 10, 10. So do I need to put... This makes no sense. I'm sure I've not had to do that before. 0, yeah, 0 and 1. Okay, cool. So OSPF, okay. Fine. But there should be inter-area networks there. or other area networks. OIA. This has come from 8. Yeah, these are all inter-area networks from the other side. Okay. Like 111. Okay. And how did it get that? Was that just... Oh, 00, yeah. It just received them from the other routers. That's really strange. I don't know what's going on there. That's weird. Hmm. Very strange. Well, I'm a little bit kind of lost for words for that. Because that should have worked. But for whatever reason it didn't, which is so strange to me. Because I'm missing an OSPF link. Which is weird, because I should have inter-area OSPF here. And that's not picking it up, so what have we got? 17, 17, 28. 18, 28, so 100, 209, 165, 100. 209, 165, 100. So that's fine. 777. 10, 10, 10. So there's something wrong with this. 51. That's fine. 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 This is weird. Alright, I'm gonna have to look at this offline. I'm not sure what's going on now, because this is really strange. That should have worked in principle, and it doesn't, which is really strange. So either I've done something wrong with my NAT, which I suppose I have done. So I'm going to just double check a quick NAT config. Static NAT. Just to be sure I'm not losing my mind. Because as far as I know, I've done that right. Since I saw static, yeah, I mean that's fine. And I'm sure that is correct. I'm not sure what's going on with the NTP server. I've no idea why we can't reach the NTP server. We should be able to do so. Yeah, IP NAT inside source static local to inside global IP, which I've done. Yeah, that's exactly what I've done. IP NAT translations, yeah. It's clearly working, so I'm not sure what's going on with that. Why we're not seeing synchronization, I have no idea. Very, very strange. Yeah. So yeah, we've set the NAT. We've set. Oh, that's another thing I haven't checked. I haven't done the NAT translations on there, have I? And show IP NAT translations. None. Okay. I can't do a call request. That kind of sucks as well. Okay, I think I'm going to end the stream there. I'm kind of tired now. I'm going to be making mistakes, so I'm going to end the stream here. And yeah, it's really strange. There's some weirdness going on in the network right now. But we'll sort it. I think I'm just going to do a quick OSPF here on this side, and maybe call this, I don't know, 20 or 30 something, maybe 31. So I'm just going to do a quick conft int. Let's see what this is. This is 000 int g000 g000, and we'll do a IP address of something like, I don't know, 40.40.40.1 255.255.252. No shut. Okay, and then I'm going to just take this, plant it onto the other side of the link, which is down here. It is 030. Conf t int 030. All right, okay. int g030. I'm going to plant that there. I'm going to do a forward 2. No shot. End it. Oh, sorry. No, I'm not going to end it. Yeah, we can end it. Copy, run, stop. Okay, conf t router OSPF 1. And we're going to be careful because we're going to do a network. And we're going to say basically it's going to be 40.40.0. Right? As a network. And we're going to put our IP mask in. It's going to do a reverse mask, so we're good. I'm going to call this area, I don't know. There's so many damn errors. Area 40. Why not? It's 40. Do we need to do anything? No. I think that's okay. Well, we've got the router ID as well, so I'm going to do exit out of that. Router. Damn. Router ID. 12.12.12.12. Because because I can, basically. Exit out of that. Interface loopback. 1. IP header 12.12.12.12. 255.255.255.255. New shit. Exit. We're going to go back to our OSPF. I'm going to do a network. 12. Not. Oh, not. Area. Whoa, area 40. End. Copy, run, start. All right. I'm gonna take this and do the same thing on the other side, basically. Conf if is good. Router SPF 1. Bung that. What our subnet's the same. That's good. And we're going to do a router ID 13. Like that. And we're going to do int loopback 1 IP address 13. Hang on a second. Yes, that's right. 255. I could have just advertised this, couldn't I? Ahead of time. 255.255. Bad mask. Why is it a bad mask? What have we got? 13. 1, 2, 3, 4. It's fine. Why is that a bad mask? We're on a loopback. Hang on a second. Let me go back. End this int conf t int loopback 1 IP header 13 255.255.255. No shut. Exit out of that. Router OSPF 1. And we're going to do a network I'm going to do 13, 13, 13. Whoa. 13, 13, 13, 13. No. Area 40. Okay. Copy, run, start. Clear IP OSPF process. Yes, and we're good. Copy, run, start. And we're going to do the same thing on this side. Just clear IP OSPF process. Yes. I'm going to do, yes. Thank you. And we've got 13 in there as well, which is good. Show IP root. Show IP root. Okay, we've got some stuff in there, but it's not the complete set because it hasn't finished loading yet. Okay, I'm getting some stuff in from different places. 13, 13, 13. And we got 30.1. 30.1. There's a strange. Was that? That's weird. I don't even see 30.1 on the MBR. I didn't even advertise that, so I'm not sure where I got that from. Oh, 108. Okay, 108's there locally. Okay, fine. Yeah, that's what I'm expecting. Inter area. Thank you. That's what I'm expecting. I'm expecting more inter area. Yeah, so that's working correctly. The transit route is working fine. Oh, that's working now. Ha! Ha ha ha! Okay. Show IP route. Okay, yeah, we're seeing some OAs as well, which is good. So we're seeing a lot more stuff, which is what I was expecting. 111 into area. So what's going on with the 66, 66, the 2, all that kind of stuff? So those, for those of you joining me, are basically what's called metrics. Those metrics are calculated based upon the cost in OSPF. So OSPF, we have a cost. So for example, if you're coming up from here, these serials, they're 64, and then you add, right? So in this case, it'll be 1, 2, because a gigabit link is 1. 1 plus 1, 66. So I should see 66 in here, which I do. So I know, for example, those 66s are coming back from there. So I mentioned this before, but I'm just reiterating that. All right, so we made some progress here. So that's pretty much working. And we've got a link going through most of the network now, which is great. We do have a couple of problems, like NAT for some reason not working correctly, even though we got show IP NAT. So we focused a bit more on NAT today, because we don't have ACLs correctly configured. Well, we've gone over some ACLs. We haven't gone through all the ACLs, but we've gone through a lot of them, like the net numbered, standard, extended. We've gone through the majority, and even the worded access list. So we've gone through pretty much all of them. But for some reason, we're still not getting our NTP server, which is kind of strange. Still says it's unsynchronized. I don't know why, but we'll do a show IP route. And even here, we're not getting the correct networks being shown. So the problem becomes this particular router here. This is a problematic router because there's something wrong with the way in which we're advertising out. I'm not quite sure why, because we should be seeing it on most of the systems. So I wonder if that's because it's either not advertising, or it doesn't want to advertise, or these are DR others. So we could do a show IP OSPF. And we could see, well, does it detect... Oh, sorry, show IP OSPF neighbor. And it's a designated router, so this is kind of strange. Because being a designated router means that it should have a full state of OSPF. So that's kind of weird. you know, being a designated router. So this is kind of strange. It's very, very interesting. But it is saying it's adjacent. So should IP root 12 isn't even noted here. So can it actually, I mean, can it? Very strange. So it did an LSA type 5. It said it found the adjacency as per this, but I don't see it in the routing table. Packet tracer really does amaze me. That's 100% a bug. Or I can do a clear IP OSPF process. Say yes. It says it's down from a neighboring router. Remade the adjacency. Detects the neighboring router on 12.12.12. So it's still sending out the thing. OSPF neighbor, so that's fine. IP root doesn't show 12. So, but 12 is advertised. So, show run. I'm not sure if it's on this. Is it on this router? 12 is on this router? It is. And it's supposed to be advertised back out. Okay, area 40 it is. It is on area 40. Hang on. Area 40, but area, it's not. Do I need to? I'm so confused, because then how is it knowing about all the other routes in the other areas? So 40 is into area, into area, into area. And 40.1. Oh, because there are networks attached to the other side, which it knows about. But it hasn't reached 51? Really? 40 is correct, 51. Blimey. Yeah, this is getting confusing. No. But it hasn't reached 50. So do I need to advertise out 51? You know what? Let me try it. Let me try it. I wonder if I need to take that and advertise this out 51. So what if I said, oh, router OSPF1 network blah, and call this 51. Oh, it changed? Why did it change? Do show run is, oh, it's on 40. So, okay, that's, I am, so 40? And, well, it's on 40 already, so it doesn't like it if, this is bizarre, then that should be advertising. Weird. Yeah, I'm confused. That should be advertising then. It should be giving me OIA, so into area, but it's not, which is weird. Because it should be advertising out the LSAs on this side. So maybe it's time we did a little bit of investigation with some debug. Debug IP OSPF. Because it's weird that we're not IP OSPF. I want to do some neighbors. Oh, yeah, adjacencies even. Do the... Yeah, do adjacencies. Yeah, fine. Simulation. Here. Ping. 12, 12, 12, 12. Oh, you're not even gonna root it out, which is so annoying. What was this? Broadcast. For what? Why is it broadcasting? What? What? A BPDU. Oh, okay. It's broadcasting a BPDU to a server and a... Okay, fine. This is not going to work for whatever reason. I'm not seeing anything in the way of adjacencies, which is really annoying. Okay. But I'm just... why? What about events? Can I get anything? Maybe if I... Okay, time out, please. Maybe... Okay, no debug. Just do a debug on the events. I want to see everything. What exactly is going on? Okay, let's give it some time. Oh, hello! Hello! 12. End of hello processing. So it received it from 12. So you received a hello from 12 as an event, and you've done the adjacency, you see him. So you should be loading the database. That is so flippin' weird. So you should be seeing the whole... Why is this router being weird? So, what? This is all wrong. This should be inter-area. If you're seeing it on 51. So why... This is bizarre. This is bizarre. It should be seeing all of these as well. Hello, come back. Come here. But you don't. So show IP route. See, I can see all the inter-area networks. Show run. 104051. Interesting. Can I see... Is this showing anything else to these routers? Or is it just... Whoa. No. So... I can only assume there's something wrong with the interfaces here. Because I would assume that if I bring this here... Oh, thank you. Ian, show IP route. There's not one configured here. Okay. Interesting. So what if I go down here? Is this... Oh, I do get 40, okay. 40 comes through 30, so I'm not seeing... some other ones. So there's a problem. There's definitely a problem. All right, I'll leave that one for tomorrow because I'm tired now. You know, or we'll do some extended access list or something because I'm still preparing for CCNA 3. My exam's on Thursday, so yeah. But there's some weird stuff going on here. So yeah, the search continues. All right, thank you for joining in on this stream. For those of you who did, and yeah, I'll see you again in the next one. Appreciate it.